How do you configure Wi-Fi with your ESP32? Are you hard coding the credentials? It's not the best way to go. So in this video, we are discussing on how you can connect Wi-Fi with your ESP32 using AP mode and a simple web server. Let's begin. So first of all, let's discuss the ways that you can use to connect your ESP32 with Wi-Fi. One method is you can hard code the credentials. It's super easy, but it will be very inconvenient when you are doing maintenance. If you need to change the router, you need to change the code. So it's really inconvenient. And another method is you can use smart config, in which you will be able to connect with your ESP32 through a mobile app, and through smart config you can provision the ESP32 with Wi-Fi. So that is one way you can use smart config plugins on your customized web or mobile application. So another method is you can use BLE. In there you are able to connect with BLE and just add the credentials through a mobile or a web application. You can just use any according to your requirement, so you will be able to update the credentials. So another method is this that we are explaining in this video, using access point mode and a simple web server. So in here we are having a simple UI for you to just add your credentials as SSID and password, and then submit it. Then the ESP32 will be updated with those credentials. So first of all, let's discuss on the difference between AP mode and the STM mode. In the AP mode, you are able to just have an internal Wi-Fi network with the ESP32. So with the ESP32, you are able to connect it with your laptop or the mobile device, and just connect with that particular internal Wi-Fi network, and then go to the specific IP. It's a default one. You are able to open that web server, and you will see that UI to add the credentials. Just add them and submit, then you will be able to connect with Wi-Fi. And then there's a station mode, which is the normal operation of the ESP32. In there, it's like when you are connected with that particular external router, you will be able to run your logic, all the processes out there, you are able to run them. So the components that you need in this setup are the ESP32 and a push button to go back to the AP mode. If you submit, you will be back in the STM mode, and if you need to go back to the AP mode, you need to click the button. So you need to have a trigger. So for that we are using a push button, and the LEDs, we are having them to show the indication whether it's connected or it's connecting, or else whether it's in the AP mode. So we are having two LEDs here, and we just show it blink when you are trying to connect, and when it is connected, it will be a solid color, and when it is in the AP mode, we are having another solid color, which is a different LED. So you need to have a breadboard and some jumper wires as well. So you need to have this circuit with some resistors and the components I said. So you can just use this circuit. And we are using Arduino IDE in here, so Arduino language is used. So these libraries should be installed, and we are giving them in the latter part of this article. So you can just click this link, download the libraries, and then use those libraries in your Arduino IDE. So now let's discuss about the code a bit. We are defining the libraries, and we are having the definition for the button, the two LEDs, and the AP credentials. AP credentials means access point credentials, that I mean on the internal network that you are having. And we are initializing the global objects for the server and the DNS server. The credentials, we are just defining them here and declaring the functions. So in here we are just defining the input and output of those digital pins, and also we are having an interrupt to go back to the AP mode. It's the button that I referred. So this is the SPIFFS. We are just initializing it. The reason is we need to have some sort of way to save those credentials. So we are using this file system in ESP32, which is known as SPIFFS. So we are saving them in there. It is a part of a flash memory. So basically, when this is the main logic in setup. So if there are no credentials out there, we go to AP mode and we run the web server for you to add the credentials. And when there are certain set of credentials out there, we just try to connect with Wi-Fi. So this is the logic. And in the loop, we are having a part to just process the trigger from the AP button. So when you click the AP button, it will go back to the AP mode. So we are processing that trigger here. And when you are connecting with Wi-Fi, we are having this function. So when you are connecting with Wi-Fi, it blinks. So when it's trying to connect, so the LED blinks. And also when it is connected, you will see a simple web server. We are just starting a web server with the IP and the STM mode IP, as well as a simple text. So in here the code snippet for that function is there, and if it is failed, we just start the AP mode again. So we are looking for like 15 seconds here, trying to connect for 15 seconds, and then if it is failed, we go back to the AP mode. And when you are starting the AP mode, we are just having this logic. We just have the AP mode functionality here with the server is on with index.html, and after you add the credentials, it will be passed to this Arduino script through the HTML file, and you will see a restart in the ESP32 after saving the credentials. After saving, it will restart. So as I said, it will be saved in SPIFFS. So when you start the web server in the connected mode, in the STA mode, you will be having this function, and it will show the IP as well as the STA web server starter text. So you will have a clear idea on that. And on the serial monitor as well, you will see the STA mode IP. You can just connect with that particular IP and internet Wi-Fi network, and then you connect with that IP and you will see that web server. And when you are reading the file, we are having this function reading the SPIFF file, and we are having this, and when you are saving the credentials, we are having this. So this is the HTML interface. So basically we are having some simple UI for that, and you can just change it as per your need. And this is the file format that you need to follow. And when you create a certain project, you will be having this file, and in the same directory as per that file, you need to have a data folder. Inside that, you can add the index.html file and add the HTML script there. So after creating the firmware, you need to upload the code. So in here, you will be having a guide to follow in order to upload. You can just click this link, and you will be navigated to this screen, and this file folder should be I think it's a zip file, so you need to download it, and after unzipping it you need to go to this directory and paste the folder there. So you will be seeing this kind of a path, and after that you can restart the IDE and you will see ESP32 sketch data upload. So just upload it, and after that the HTML file will be uploaded, and then you can go trying installing the libraries. So you can click this link and it will be navigated to a Google Drive. You can download the library folders and just install it by following this process. In there you need to go to Documents, Arduino Libraries, and just paste the unzipped folders there, all the libraries that we have included here. And when you are uploading the code, you need to have the ESP32 board installed. So when you are installing, you need to have this version as well. This code is like it's working only for this version. So if you are having an upgraded version, you need to change some parts in the code, and you need to change it in order to upload that. And also you can just before doing that, you can just upload the code, and then you can do testing. Basically, when you are testing, you need to connect with that internal Wi-Fi network. You can add these credentials and connect with that internal Wi-Fi, and open the browser, type this default IP, and you will see this. You can type the SSID and the password there of your real router, and then click submit. So after that, it will be in the STM mode. In the STM mode, you can add any code logic out there. So it's according to your requirement. You can change the UI as well in the STM mode to have some inputs. So the ESP32 will receive those inputs and have some processes to communicate with the cloud. So you are able to customize it, and this is how the serial monitor shows when you are connected with the STM mode, and this is how it shows when the AP mode has started, and when you click the button, it will go to the AP mode. So if you have any issues, you can contact us at info@protonix.co or udaru@protonix.co, and you can check our website on www.protonix.co. and if you have any project related to IoT, you are able to contact us, and we will be happy to help you. And thank you so much for coming through the video and coming to the end, and hope you enjoyed it. Thank you so much. Have a nice day. Introducing our IoT system design tool. Configure the right sensor, actuator, communication method, power, PCB design, cloud servicing, storage, human interfaces, enclosures, and much more. If you need any help on choosing, you can use our articles as guides. Learn while you order, or simply upload your requirement. Are you ready to bring your IoT ideas to life? Visit us on iotsystemdesigntool.protonix.co.